Hello. Hello, and welcome to this 50-second set of problems. And the description will contain the link for downloading the PDF. There are two things I want to say. One is that always use pen and paper when you watch the video. Solve the problem while playing the video. Pause the video when the problem is being stated. And only if you cannot solve the problem, you should look at the solution. At the end of the video, I will show you how you can download the PDF. This one and trigonometry one as well. So question 511 says that if x and y satisfy the equations y is equal to 2, that is the integral part of x, plus 3, and y is equal to 3 into integral part of x minus 2 simultaneously, determine integral part of x plus y. So we have one equation is that y is equal to 2 into integral part of x plus 3, and y is equal to 3 into integral part of x minus 2 is equal to y. Implies that y is equal to 3 into integral part of x minus 6. So let's see if this equation which we wrote is valid. Let's say 3 can make the fractional part when multiplied by stuff weird. So first we pick something less than 0.33. So let's assume that x is equal to 2.3. So then the integral part would be 0. And here, if you see, it would be 3 into 2 minus 6, it would be 0. So that is correct. Now let's take another value between 0.33 and 0.66. So this will become 0.66, or 2.5 we take, it will become it will become 0.5, and integral part would be 0. So still true. Similarly, for for numbers greater than 2.66, this will hold true. So we see that this equation is true. Now we have two equations, one in y, one in integral part of x. So we solve, we get y is equal to 21, and integral part of x is 9. So integral part of x plus y is equal to 30. Question 512 says that if x is in the set of real numbers and a1, a2 through an are also in the set of real numbers, then find the value for which sigma I is equal to 1 to power n x minus ai whole square is least. So we can write x minus ai whole square is equal to x minus a1 whole square plus x minus a2 whole square through x minus n whole square. So if you sum that, it will become an x square minus 2 a1 a2 through n into x plus a1 square plus a2 square and through n square, which is a quadratic equation. And for a quadratic equation, we know that it will achieve its minimum value when x is equal to minus b by a. Okay, b is the coefficient of x and a is coefficient of x square. So using that logic, we get that the least value will be at this, that is a1 plus a2 through n by n. The second way of doing this solution is using maxima and minima and calculus. You differentiate this, you get 2nx minus 2 into a1 plus a2 through n. And then you equate the dy by dx is equal to 0, you get a1 plus a2 plus n by n. And if you differentiate it once more, you get n, which is greater than 0. And therefore, this will be minimum value. Question 513 says that let there be a quotient of two natural numbers in which the denominator is 1 less than the square of the numerator. If we add 2 to both numerator and denominator, the quotient will exceed 1 by 3. And if we subtract 3 from both numerator and denominator, the quotient will be between 0 and 1 by 0. Determine the quotient. So it is given that n is in the set of natural numbers and the quotient will be n by n square minus 1 according to the question. Now it is given that when we add 2 to both numerator and denominator, it becomes greater than 1 by 3. So from this, n plus 2 by n square minus 1 plus 2, we get n square minus 3n minus 5 less than 0. That means n will lie between the two roots, and the two roots are 3 by 2 minus square root of 29 by 2 and 3 by 2 plus square root of 29 by 2. Also given that when you subtract 3 from both numerator and denominator, you get it between 0 and 1 by 10. So we get this limit 0 less than n minus 3 by n square minus 4 less than 1 by 10. So we take the first inequality n minus 3 by n square minus 4 greater than 0. So you solve this, you get minus 2 less than n less than 2. How do we get this? So let's assume that if we solve this n square minus 4, then we get 2 roots, and we assume n is less than 3 here. So top or rather numerator will become negative, and the denominator will negative between the range minus 2 and 2. So negative divided by negative will become positive. So that is minus 2 and less than n less than 2. And when you assume that n is greater than 3, it will be always positive. So n will also lie between 3 and infinity. Now we take the second inequality and we solve. So we get this equation. Okay. Again, using similar method, you solve and you get n is greater than 2. So now we combine the inequalities. We get that n is greater than 3 and less than 3 by 2 plus square root of 29 by 2. So n is equal to 4 and our quotient would be 4 by 15. Lengthy problem but simple. Question 514 says that let f of x be a quadratic expression which is positive for all real x. If g of x is equal to f of x plus f dash x plus, I shouldn't read it f dash, I should read f prime x plus f double prime x. Then there should be a then for all real x show that g of x greater than 0. So f prime x means differentiation of fx and f double prime x means double differentiation of f of x. So if you don't know calculus, you can skip this question. So we let f of x is equal to ax square plus bx plus c because it's a quadratic expression. So then gx will become x square plus b plus 2a into x plus 2a plus b plus c. And given that the quadratic expression is greater than 0 for all x in set of real numbers, that means if it is always positive, both the roots will lie in the complex plane. That implies that b square minus 4ac less than 0. This also implies that a is greater than 0. Now we take the discriminant of gx. Discriminant of gx is b square minus 4ac minus 4a square, which will be less than 0. And that means roots of gx will also lie in the complex plane. And that's why we can say that gx will be always greater than 0. When both the roots lie in the complex plane, the parabola will be always greater than 0 if a is greater than 0. Question 515 says that by considering the quadratic equation f of x is equal to a1x plus b1 whole square plus a2x plus b2 whole square through anx plus bn whole square, prove the inequality a1 b1 plus a2 b2 through an bn whole square less than equal to a1 square plus a2 square and through n square into b1 square plus b2 square through bn square. So you see that if you look at f of x, it's a quadratic equation. So if you solve this, you will get a1 square plus a2 square through an square x square plus 2 into a1 b1 plus a2 b2 through n bn. And constant term would be b1 square plus b2 square through bn square, which would be greater than or equal to 0. Okay, because x is in real numbers. Okay, so if x is a real number, this will be always positive. Now, discriminant of the corresponding equation would be less than or equal to 0 because coefficient of x square is positive. So we get 4 into a1 b1 plus a2 b2 plus through n bn whole square minus 4 into the coefficient of x square into constant term less than or equal to 0. That implies that a1 b1 a2 b2 through n bn whole square less than or equal to a1 square plus a2 square through n square into b1 square plus b2 square through bn square. Now question 516 says that find the real values of m for which the equation x into x plus 1 into x plus m plus x plus m plus 1 is equal to m square has 4 real roots. So we don't want complex roots here. So we multiply everything or rather not multiply everything, we bring it into two terms, okay? So what we do here is we write the equivalent equation, we get x square plus m plus 1 x plus m. So we multiply x plus 1 and x plus m. Then we multiply these two, we get x square plus m plus 1 into x is equal to m square. Now we let y is equal to x square plus m plus 1 into x. The equation becomes y square plus my minus y square. So y is minus m plus minus square root of 5 by 2. So first we consider one value and we get 2x square plus 2m plus 1 into x minus square root of 5 minus 1 into m is equal to 0. And the second value will give us 2x square plus 2 into m plus 1 into x plus square root of 5 plus 1 into m is equal to 0. So we have two equations, we will get 4 roots if both equations have real roots. Okay. Now we look at the roots or discriminants rather. We get 4 into m plus 1 whole square plus 8 into square root of 5 minus 1 m greater than 0. And 4m plus 1 whole square minus 8 into square root of 5 plus 1 into m greater than 0. So solve these two quadratic equations and you will get following values for m. That is mod m greater than 2 plus square root of 5 and mod m less than square root of 5 minus 2. Question 570 says that find all real values of a for which the equation x square plus a minus 1 x cube plus x square plus a minus 1 into x plus 1 is equal to 0 possesses at least two distinct negative roots. Okay, we need two distinct negative roots and we want real values of a. So given equation is this. So what we can write this as x plus 1 by x whole square, you divide the entire thing by x square, okay? You will get x plus 1 by x whole square minus 2 into x into 1 by x plus a minus 1 into x plus 1 by x plus 1 is equal to 0. We substitute y is equal to x plus 1 by x, we get y square plus a minus 1 into y minus 1 is equal to 0. We compute the roots, we get minus of a minus 1 minus plus square root of a minus 1 whole square minus 4 by 2. Once we have these two roots, we bring the original equation, that is x plus 1 by x is equal to y. We get 2x square plus a minus 1 minus square root of a minus 1 whole square plus 4 into x plus 2. And the other root we substitute, we get this equation. We let alpha beta to be the first roots of first and gamma beta be the roots of the second equation. Then we get alpha plus beta is equal to this term and gamma plus delta is equal to this term, and alpha beta will be 1 and gamma delta will be 1. Now for this to be real root, right? We need real roots, or no, we need negative roots, okay? Now for this to be negative root, square root of a minus 1 whole square plus 4 should be greater than a minus 1. So that means we know this, why this is greater than a minus 1 is, reason is we want negative roots. So alpha plus beta will be greater than 0 and alpha beta greater than 0, which means alpha beta are positive. And thus the other equation must have two negative roots. So one equation has positive roots, another equation has negative roots. Alright, I think I made a mistake by saying that this is greater than a minus 1 because the roots are negative. That is not true. This will be always greater than a minus 1. Okay, it's simple inequality. So this equation, the first one will have positive roots. So this one will have negative roots. Now for roots to be negative, discriminant should be greater than 0. So we compute the discriminant. The discriminant which we compute was, or the roots to be positive, we have this equation, okay? This one, not this one divided by 2. So essentially the numerator should be greater than 0. So we solve this equation and we arrive finally at a should be greater than 5 by 2 and less than infinity. Again, I said that numerator should be greater than 0. That is not true. We do compute the discriminant of this equation, okay? This is a minus 1 plus square root of a minus 1 whole square plus 4 whole square minus 16. So 2 with a 4, 4 just 16, and this is square. Now we move on to question 518. Find the real values of the parameter a for which the equation x to the power 4 plus 2x cubed plus x square plus 2x plus 1 is equal to 0 has at least two distinct negative roots. So similar question. We proceed similarly, we divide by x square and we arrive at x plus 1 by x whole square minus 2 into x into 1 by x plus 2 into x plus 1 by x plus 1 is equal to 0. Like last problem, we take x plus 1 by x is equal to y. The equation becomes y square plus 2ay minus 1. And the roots of y would be, or rather this quadratic equation would be minus a plus minus square root of a square plus 1. So we take first root and we evaluate for x. We get x square plus a plus square root of a square plus 1 into x plus 1 is equal to 0. And similarly, we have, when we pick this root, we get this equation, and when we pick negative root, we get this equation for y. We let alpha beta to be the root of the first and gamma delta to be the root of second equation. So alpha beta for the first case becomes square root of alpha square minus 1 minus a, and alpha beta is equal to 1, and gamma plus delta becomes minus of a plus square root of a square minus 1 plus 1, and gamma delta is 1. So clearly upon observation you see that this alpha plus beta will be always positive and gamma plus delta will be always negative. So gamma delta will be negative, which means the discriminant of this particular equation, the second equation, should be greater than 0. So we compute the determinant and we find a is greater than 3 by 4 and less than infinity. Now we have a, b, c in set of real numbers. A is not equal to 0. We have to solve following system of equations in x. So what is given is ax1 square plus bx1 plus c is equal to x2. ax2 square plus bx2 plus c is equal to x3. Then it will be x3 square plus bx3 plus c is equal to x4, and so on up to axn square plus bxn plus c is equal to x1, where when b minus 1 whole square less than 4ac, and when b minus 1 whole square is equal to 4ac and b minus 1 whole square is equal to greater than 4ac. So three conditions. So this looks like a quite difficult problem. Okay, let's see how we solve this. So we write that ax1 square plus b minus 1 x1 plus c is equal to x2 minus x1. So we subtract x1 from both left hand side and right hand side. And similarly for the second equation, we subtract x2. This should be x2, okay. And for the last equation, we subtract xn minus 1. So now we sum all the left hand side, which should be 0. Now when b minus 1 whole square minus 4ac less than 0, all the equations will have same sign as that of a, okay. That means sum would not be equal to 0. So the given system of equations has no solution. When b minus 1 whole square minus 4ac is equal to 0, so all the functions, all the equations on the left hand side would be greater than 0 or less than equal to 0. So from our equation, we have that sum would be equal to 0. That means f of x1, f of x2, all will have to be 0. That means that if we take the ith term, then a or ith line, then axi square plus b minus 1 xi plus c is equal to 0. So xi is 1 minus b by 2a. So all the roots will become the same root because they have all of them have the same root. Okay. Now we look at the third case when b minus 1 whole square minus 4ac greater than 0. So we take the roots, we get 1 minus b plus minus square root of 1 minus b square minus 4ac by 2a. Now if x1, x2 through xn lies between alpha and beta, then sum would not be equal to 0 because it is either less than 0 or greater than 0, as a greater than 0 or less than 0. If x1, x2 through xn lies between minus infinity and alpha or beta infinity, also then sum would not be equal to 0. So if either roots are alpha or beta, then f of x1 plus f of x2 through f of xn will be equal to 0. So even though it looks quite difficult problem, you have to just observe that what is given here, b minus 1 whole square in all three cases. So you want b minus 1 here. So you subtract x1, x2, x3, and on the right hand side also you do that. Now we solve question number 520. We have to solve the inequality log of x square minus 3 by 16 with base x greater than 4. So pretty straightforward problem. When x is greater than 1, we will have x square minus 3 by 16 greater than 0. So we take the log, we get x square minus 3 by 16 greater than 0. So x will lie between, x will be less than minus square root of 3 by 4 or x greater than square root of 3 by 4. Now x square minus 3 by 16 greater than x to the power 4. So we see that 1 by 4 will be less than x square less than 3 by 4. So we see that no value of x will satisfy the inequalities at the same time. You have to solve this equation, okay? You take x square is equal to y and then you solve. Now when x is less than 1, we will have x square minus 3 by 16 greater than 0. Why it would be greater than 0 is because x square minus 3 by 16 will be less than 1, okay? And this will be less than 1 also. Hang on, let me see. This will be greater than 0 when x is less than 1. It won't be always greater than 0. There is a chance that it will become less than 0. Okay, let me think a bit. Case 2, when x is less than 1. Okay, now if x is less than 1, right hand side would be 4 to the power x. So it is obviously greater than 0. Right hand side would be 4 to the power x. So if x lies between 0 and 1, then it would be greater than 0. So we impose the same set of inequalities and we arrive at the same result almost. X square should be less than 1 by 4 and x square greater than 3 by 4. So from these two, we get the set of equations that is root 3 by 4, comma 1 by 2, union root 3 by 2, comma 1. Now we come to the last set of the last problem of the set, 521, because I said that I will solve 11 questions in the last remaining 4 sets so that we can finish this in 4 days. Question 521 says that find the values of m for which every solution of the inequality log x square with base half greater than or equal to log x plus 2 with base half is a solution of the inequality 49x square minus 4m to the power 4 less than or equal to 0. Now we are given that log of x square with base half is greater than or equal to log of x plus 2 with base half. Now since base is less than 1, we say that x square less than or equal to x plus 2. That is, sign of inequality has changed. That is, x square minus x minus 2 less than or equal to 0. That is, it lies between minus 1 and 2. Those are the roots. But for the logarithm to be defined, x should not be equal to 0 and x should be greater than minus 2. If it is not greater than minus 2, then it will become negative. So once we have that condition, we look at 49x square minus 4m to the power 4 less than or equal to 0. So this gives us 2 by 7 m square less than or equal to 2 by 7 m square. Hey, this should be x square. One thing should be x square. So we bring 4m this side, or rather 49 this side. So, okay, you can see which one is which, okay. We want x. So x square would be less than or equal to 4 by 49m to the power 4. So there will be two roots, minus 2 by 7m square and 2 by 7m square. So what is missing is, it should be read as minus 2 by 7m square less than or equal to x less than or equal to 2 by 7x square. So less than and x are missing here. Alright, I'll fix this. Now from the question, we have that from this condition that x lies between minus 1 and 2. So minus 1 by 2 should be a subset of this newly obtained range. That means minus 2 by 7 m square should be less than or equal to minus 1, that is m square greater than or equal to 7 by 2. And for the other end, we have 2 by 7 m square greater than or equal to 2, that is m square greater than or equal to 7. That means m should lie between minus infinity and minus square root of 7, or between square root of 7 and infinity. So with this, we come to the end of 52nd set of problems. There are two typing mistakes. One is this in the last problem, 521, and there was another typing mistake, which was the spelling one. Where was that? I forget all the time. So let me quickly look at that. Okay, I'll find it. It doesn't matter, okay? I'll find it. Where is the typing mistake? It was probably in 514 or something, okay? All right, I'll find the second mistake. So we have two mistakes, and one is in the 521. Okay. So I'll update the PDF, and if you want to download the PDF, you can come to my website ashtavak.org and look at the second link. It is the algebra PDF, and third is the trigonometry. The date shows when the PDF was updated. It was last updated on 12th April, and this was updated on 24th January. So with this, we come to the end of this video. So the problems were quite interesting, and I hope you enjoyed it, because having fun is important while studying. So I wish you all the very best for your exams and studies, and I will end this video here, and I'll see you in the next one. Till then, keep practicing. Thank you.